Okay, going live. My goodness. YouTube wasn't letting me go live for a second. That was crazy. Hi all. Hopefully you can hear me, you can see me. I'm hoping. If I get any echoes, please tell me if I am, hopefully I'm 5x5. I see, or 5x9 rather. I see both Mike and Jerry are in the chat. And thank you. They are both moderators. They'll be the moderators for today. They're always the moderators. Who am I kidding? I'm very grateful to them. They will make sure that you are, hang on, make sure we don't get an echo. Okay. They will make sure you guys are being good to each other and good to everyone and good to me as well. So let me know if you guys can hear me and see me and everything looks good, and we will jump into everything. Okay, Mike says audio is good. Fantastic. Teresa says we keep getting electrical outages. Ouch. I hope that's, yeah, I hope that's not a problem for you right now. As you can see, yes, good. Everything's fine. Good. 5x5, 5x9. We're good. Excellent. Thank you so much. Okay, guys. As you can see, I'm not wearing a red shirt, despite the fact that we have multiple solar storms headed our way. And you'll find out why that is here in a minute. We also have more active regions than I can even remember on the disk at one time. We've had, over this past few days even, we've had something like 18 active regions. So when you look at the sun, it's literally peppered with stuff. So yes, no red shirt. Steffi B says no red shirt. I did it on purpose because the solar storms that are coming, and despite the fact that we have all these active regions in Earth view, things are okay. Don't worry, there's no doom and gloom. And if you believe anyone who tells you that there is doom and gloom coming, they're just, once again, after the clicks and likes and trying to be a bit too, you know, sensational. Let's just put it that way. So, pump up the audio, please. I might be able to turn it up just a smidge. If I turn it up too much louder, then I will likely get distorted, and I don't want to do that. Let me see here. Check, 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 check. I might be able to turn it up just a smidge here. Check, 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 guys. Is that a little bit better without being too distorted? Hopefully. I'm almost in the red. So that's as loud as I want to go. Any distortion? We're good? Talk nerdy to me. Yes, I sure will. I'm very good at that. Okay, good. Excellent. Yes, better. Okay. Thank you. I appreciate the feedback, guys. So what I will do for those of you who are, you know, busy, have full lives and want to get on with your day, I will give you the BLUF, which is the bottom line up front. That will be the forecast. This is a solar storm forecast, so it will be a little bit more intense than typical, so it will be a little bit longer, but I'll try to keep it as fast as possible, get to those 5-day outlooks, and then we can back up and do deeper dives and things like that because I have my other rig ready in case we want to do some of that for a nice Q&A, okay? So let me change everything here. Good. Everybody's saying my audio is great. Okay, so let me go get rid of the chat for now, and we shall get started. As you can see, yes, solar storm briefing. Okay, let me stand on this side. Now, here's our sun right now. This has actually been for the past week. I actually started it back on the 13th because I did want to go over those big X-class flares that we had over this past week. They didn't, believe it or not, cause any of the solar storms that are headed towards Earth. But we've been watching region 37, 38. This region is now rotated off of the Earth sun, you know, out of Earth view to the sun's far side. We'll talk more about that in a little bit. But this is where we actually did have one of the big X-class flares on the 14th. You can see it right about here, bam, right there. That was a big X-class flare. I will talk a little bit more about the impacts to the radio bands. It really wasn't all that bad. I actually searched through the radio for radio bursts, and we had some long type 2 radio bursts, but there really weren't that much, there wasn't that much up at really high frequencies. So Starlink and all of that kind of stuff should have been just fine. We've really not had any big flares with high frequency radio bursts for quite some time. But as we continue, look at all of these active regions. It's like, oh my goodness, look at them all just pouring on the disk. It became so cluttered, I had to actually minimize the size of the numbers here just to be able to make sure they weren't going to run all over each other. So it's been quite amusing trying to number all these things. What the funny thing is that not a lot of them have been all that active. You'll see region 3751, we'll talk more about that. That's the one that's actually causing trouble for us now. But right around the 16th, late on the 15th and into the 16th, you'll see region 3753 kind of pop off a few times, along with some active stuff going here. There's a big one right there. That actually did launch a solar storm. This is a solar storm that we've been dealing with for over the last day or so. I don't know if any of you have been watching the real-time solar wind, but we have been kind of getting some ratty solar wind. That's from this, mainly southwest directed solar storm. We're not really getting all that much from it, but there is a little bit. You can see right in here, this looked like it was actually going to go northwest of Earth, but if you watch carefully, you can see that kind of there's a little bit of something that trails down in here, and I think that's pretty much what we're getting. So it's this region, this very ugly, I don't even call it a halo, partial halo in this region that has been giving us trouble over the last 24 hours or so. It's not the one that we've been expecting to hit. The next set of regions actually, okay, we had a big X-class flare here. This was on the 16th once again from region 3738. This did launch a big solar storm completely west of Earth, so no big issues there. Just because we have a big X-class flare doesn't mean we're going to get a solar storm that hits Earth. That is actually moving off. It's already basically past us. And I'll talk a little bit more about the radio blackout issues from this one. This particular solar flare actually caused us a little bit more trouble on the bands, and that was because it had this very long sweeping Type 2 radio burst that I'll show you in the deep dive if you want to see, but it was really intense. It kind of surprised me. But we get, once again, nothing in the super high frequencies. So we'll talk a little bit more about that in a few minutes when I bring up the geochron. But what we're starting to look at now is we're going to start looking at again, region 37, 44, and 48, as well as 53. And this region in here, you're going to see a lot of activity in here, and you're going to see like a filament style something right in here that pops off. I believe it's this filament here. You'll see that, and that'll be really comprise the storms that are actually we're waiting for, that have been kind of slow to reach Earth, but we're expecting them at any time. And there we go. So you see this kind of this like lightning bolt. I'll back up a little bit. See this little, you'll see a poof here and kind of a connection to that one. Do you see that kind of thing? Yeah, I'm really good with sound effects, right? So then that one, and let's see if I might have to go back. Yeah, because this is the bigger one. Let me go back here because I showed you the connected kind of shot that came from these two regions here. But there was also something down here. Let me back up just a little bit and see. Can you see that right here? Watch this between 3750 and 49. Watch for a little lightning right there. See all that? That junk? Well, that was part of a solar storm that launched. It even had a little something that came off up here. Kind of hard to see, because all these regions are connected to one another, so they're all synergistic, and they're all kind of, letting a little bit of stuff go at a time, which makes it really complicated and very, very difficult to forecast. So we had this kind of thing happening here, we had this kind of thing happening over here, and what that led us to, and I only have this connected to this region, but I really should have this coronagraph image connected to all of these regions because there's just so much going on. What you'll see is, for those who are good at looking at coronagraph images, right, this is the intensity image, this is the difference image, because you can't always see stuff in the intensity image all that well, so you actually do difference of the frames to be able to pull out the features. What was dense becomes not dense, what was it wasn't dense becomes very dense between frame to frame to frame, so you can subtract them from one another and really pull out the features, and they become more black or white as opposed to the gray. And that really lets you see these things pop out at you. So what you see here, if you're not careful, it looks like a full halo, right? It looks like a completely, almost a three-quarter halo. You'd think, oh, there's just one solar storm. Actually, no, these are two solar storms. You've got one on this side, right here, and then you've got one on this side, okay? And if you wonder what I'm looking at my TV here, so I can actually put my finger where it matters. So that sounded strange. Okay, so here's the second storm, here's the first storm, right? And they're kind of coming back to back. So for those of you who have actually looked at it, was really nice that the Space Weather Prediction Center, when they did a modeling event recently, I think it was Sean Dahl probably put up this really nice graphic that tried to show that there were actually two storms. I thought that he did that really well. And so that's what they modeled. So when we talk about the NOAA's Space Weather Prediction Center, there's their NLO model run, their solar storm prediction run. We'll talk about that. I'll show you the 2 storms that they modeled. These are the 2. Okay, so it looks like a single halo, but it's really kind of a composite thing. And both of these are partly Earth directed in of themselves. So there's at least 3 solar storms coming at us. Wow, right? Okay, so that's number 3, or 1, 2, and 3. Then we get another pop right here. Do you see that little lightning bolt kind of thing? That lets off a solar storm. We'll talk about this for just a second. In coronagraphs, again, not all that pretty. Right, you're looking at a kind of a partial halo. That is barely going to be grazing us, but coming by us, not moving too fast. If you notice, none of these storms seem to be moving all that fast. They're not like explosive out of the sun. So this one's also coming towards us. I don't think that that's been modeled all that well. We might even have a little bit of something up here, right there. If you saw that, that was an M-class flare. If it poofed something out, it was very minor. It was kind of clouded in the coronagraph, so I don't even bother showing the coronagraph for that one. And then what I'll do now, okay, as we continue taking a look at all of these active regions, notice region 3751 is continuing to get more and more active here. This is the main flare player on the disk right now. Most of these others are just kind of giving us like little pops like this, just little peppered popcorn all over the place. They're not really all that big and scary, to be totally honest. But did you see I now have expanded the corona so we can see the mid-corona a little bit better? And that's for 2 reasons. One is we have a region, you'll see some really nice eruptive activity going off this way. And then also because of this solar filament right here, you're going to watch this filament erupt. That's right, and we had another filament erupt and I completely scooted right by it, but watch this. So there's this, you see a little bit, you have to put your eyes in 2 places at once. You have this region here, you watch this little pocket evacuate that way. That's a big solar storm launching. And then this gorgeous filament launches this way too. I'll back up a little bit so you can see them both again. So let's focus on the filament first. You can watch it launch, whoosh, right like that. You see that pretty ribbon. And then you can also see near simultaneously, you get this, see how it's all fuzzy? And then whoosh, there it goes. So those 2 launch nearly simultaneously, and what that does is that it gives us a coronagraph that really looks kind of ratty. You've got that solar storm launching that way, and then you've got this filament, which, look at this. It's kind of a 2-parter. Let me back up a little. Come on, there we go. So you see part of the bottom of it here, and you see this part here. The problem is that we've got this little lip. That's the top part of it. It's almost crossing center disk. Do you see the top part of this? So I was actually asking one of the M2M forecasters, Corinna Alden, who's one of their premier forecasters out there. She was sweet enough to chat with me. She was looking at this last night prior to modeling, and she's like, oh, I'm going to leave it to the morning shift and get their second opinion. And so I'll show you the forecast that they put out with that. It looks like it is going to miss us. At least that's what the modeling shows thus far. But it sure is on the hairy edge. And plus we've got this coronal hole down here in the south that might actually cause, depending upon what the solar wind is doing down there, if it pushes up toward the equatorial, the ecliptic plane, then it might push this into the Earth strike zone just a smidge. So once again, we have now, this is the 5th solar storm that is honestly grazing us. It's not going to be getting us, if we even see much of a disturbance from it at all. So that is the reason for the gray shirt. We have 5 solar storms, and yet they're really not doing all that much. In fact, when I show you the modeling, you'll see the solar storms, the 2 solar storms that were the halos that we were expecting to see. Those haven't even arrived yet, and from the data, it doesn't even look like they're driving shocks anymore. So they're going to be pretty slow going. Will we get some aurora down at mid-latitudes? It depends upon how strong the magnetic fields are from these. I'm not, at this point, because they're fashionably late and I don't see them driving shocks, I'm kind of losing a little hope that we're going to see anything more than aurora at high latitudes. But if we do see some aurora, it could be very extended because we have so many of these solar storms. on their way. And as you can see, a lot of stuff still going on. We do still have a lot of active regions that are beginning to rotate into Earth view. We'll talk more about that in just a second. Also, we're going to be paying attention to region 3757 because it seems like it is waking up along with these regions here, which have been showing quite a bit of activity. Now, I believe what comes next is, yes, the far side. So as I take a look at the far side of the sun, this is a synoptic sun image. Hopefully you guys can see the numbers here. So this is SUVI. This is, I'm looking at SUVI 304, and this is also solar orbiter. Thank you to EUI imagery on the sun's far side. We are literally seeing the active regions as they build up. You can see, actually, let me talk about region 3738. It is alive and well. As you can see, as I move this sun map over, it is very, very much alive and well on the sun's far side. We have these other regions that have been pretty active, where we got the X-class flares, regions 3743. That is now rotating to the west, or off of the west limb onto the sun's far side. So we'll be paying attention to that. And we're having region 3733 about to rotate back into view. If you look at this through helioseismology, it looks like a very big dark patch. So region 3733 looks like it's actually quite interesting, and it is, as we've seen. You saw it launching a big solar storm just, today, a little bit earlier today. So I believe it's definitely a big solar storm player as well as a solar flare player. So we're going to be having more activity from this region rotating into Earth view. And these are new regions in here. So these will be rotating into Earth view in about maybe 4 days. Is that about right? Yeah, maybe 5 days. Okay, so we're going to get some. But this is the big one to pay attention to, and this is going to be rotating into Earth view in about a day or so. We have old region 3737 that's rotating into view now. So we're dealing with that. But I think this is the one that's actually going to be giving us big solar storms if we have a chance, and big solar flares again, if it is as active on the front side as it's been on the far side. But all of those big active regions, and I don't know if I have to move this back. I think I have to move this back. Let me back it up a little bit so you can see once again just the active regions on the disk, because I didn't label them all. Look at all these active regions. All of this is going to thankfully move off. So we're no longer going to have nearly the level of our number of spots that we've had, or spot clusters on the disk that we've had this past week. So take a snapshot, put it in memory. We'll keep it as a record. 18 at one time, I think, was the max, maybe 19. And we'll see if we can, beat that. But welcome to solar maximum if you didn't know what it looked like. But don't let anybody fool you into thinking that the sun is losing its mind. It's not. It's fine. None of these regions seem to be all that busy, interestingly enough. So activity has been mild, to be totally honest. And I'm more worried about the bigger regions that can give us the big extreme storms. But we don't see anything like that on the disk right now, okay? So once again, I'll let this play, and then we'll move into looking a bit at the X-ray flux and talking about the radio blackouts, because that's what I'm sure has been on a lot of people's minds recently, right? Okay, so, I guess it did do that. Okay, now, as we take a look at our X-ray flux, you can see I've started this back on the 12th. You can see the X-ray flux. We've been sitting above the sea floor for quite some time, almost at the M flare level for the noise floor. So this is why over the past week it's been so nightmarish for amateur radio operators on the Dayside. We have been popping quite a few M-class flares. Here's the first X-class flare, and we'll talk about that in a sec as soon as it begins to move. Are you going to move for me? I don't know. Are you moving? There we go. Okay. I was going, is it going to move? So in just a moment, it should pop up and show for this X-class flare, it should show the geochron data. Here we go. So back on the 14th, basically it was during the Dayside. The Dayside was basically in the Asian Pacific, and when that X-class flare went, you can see we actually did have a lot of contacts that kind of broke off and got pretty quiet, but it didn't completely deaden all of the contacts. So we didn't, and that's because we didn't have a radio burst that went way up into high frequencies, and it really wasn't all of that intense. So despite being an X12, it was reasonably impulsive, not really all that coherent, and really where some of the intensity died down, I mean, where it actually caused problems for HF, especially HF and UHF bands, was more from the decay of that particular event. Let me turn around for a second and catch it right here. So here's the X-class flare. It was actually on this part where it was kind of coming down right before it popped the M, you know, that came shortly thereafter. And that's because we just have so many active regions clustered together that there's just a lot of complexity. So we're getting lots of little, like one flare will inspire another one to go because they're all connected magnetically. Now the second one, the second flare was back on the 16th about midday, and we'll get some, hopefully this will come up here in a second. We'll see geochron, there we go. In this case, we actually were dealing with the day side of Earth being basically over the Atlantic. So it kind of nailed Europe as well as part of the Pacific as well. So those of you who remember the X-class flare, it was an X 1.9 or essentially an X 2.0, which I've got it written here. It did really take out for a short while, took out a lot of DX across the Atlantic over many frequencies. So that one was a bit more intense to deal with. It also had that big frequency sweep. And so those of you who were dealing with it, it lasted a lot longer. Since then, though we've been just popping M-class flares because both of these were from region 3738, no, 37, oh poop, I can't remember. I think, yeah, 3738. I don't think region 3743 did X-class flares. They've been popping more of the M-class flares. And now more recently, as you can see, our noise floor has kind of died down a bit more. We're sitting at low-level M-class flares, and most of them are pretty impulsive because we've just been getting all these little pops and poofs and things, mainly from region 3751, but we are starting to pay attention to 3761 and also 3753, I believe. So we'll pay attention to those. Still not too worried about them. I think the conditions are going to continue pretty much as they have been. So expect that radio propagation on Earth's day side will be a little bit better, but we're going to be obviously looking at region 37. What is it? The old region 3733 that's going to rotate back into Earth view over the next couple days, and that could change conditions again. All right, now we're going to switch to our solar storm prediction model. This is Enlil. This is NOAA's version of the model. Top panel's density, bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as I set this in motion, hopefully, there we go, you're going to see the two solar storms. I'm going to stop this for a sec. Remember, we're talking about the two solar storms that made that halo, right? That what looked like a single halo was actually two different solar storms being launched. You'll watch them both being launched. Here's one, and then the second one is right behind it. One of them is going off, if you recall, one was going to go off to the east. The second was going to go off to the west. One is kind of, I think, going north of us, and then the other is kind of going a little bit to the south of us. But as you can see, they have them kind of somewhat merging together as we look at the north-south cut along the Earth-Sun line. You can see the first one they're kind of merging a little bit together here. So what we get is early on, what they expected was early on the 20th. This is UTC time, of course, that we would get the first bump up, okay? And then as hopefully it will continue here, there we go, to the second one. When the second one hit, this was actually going to be early on the 21st. So that's where we're going to get the bigger bump. And when you see the 5-day outlooks, that's why you'll see everything's peaking on the 21st in terms of activity. They have been fashionably late. We have not really seen anything. We've seen some stuff ahead of time on the 19th, but remember I mentioned those other solar storms that had launched prior to these, and I believe that's what we're seeing right now. I don't think we're seeing these partial halos hitting us yet. I do think they are yet to come. But because they're so fashionably late, I don't really have a lot of hope that they're going to be all that strong. They're just going to be convected with the solar wind, so moving quite slowly at this point. Now, we did have that solar filament, and that one has not been modeled by NOAA yet, but this is the NASA model, the M2M model that Corinna Alden and the M2M team have put together. I was hoping that it would be a little bit better of a hit, but yeah, you got to get what you got to get, right? So as I put this into motion, by the way, again, this is Enlil. You're looking down at the sun from the North Pole with Earth being off to the right here. And you'll see this kind of really weak structure. Now, it looks super small right here. The reason why it looks super small is because it's actually south. Oh, you can't even see it. It's off of the Earth-Sun line, so sadly, you don't get a good cut this way. We really should make these models have better slices through them. We need one where they have a slice right through the plane of the the center line of the solar storm, so that we always can see what the solar storm cross sections look like. But okay. Anyway, that's a conversation I need to have with the modelers and the production team. Anyway, so this is the solar storm. It's mainly southward of this what we call the ecliptic plane, so it looks really super tiny. As we look at the splash screen here, this is where it's actually the impact footprint. You can see the main bulk of it is definitely going to be south, because here's south this way, southeast of Earth. I do think that there's a good chance that we'll have some level of disturbance from this. I don't think it's going to be, it may not even be like recognizable as a big solar storm, in the solar wind data, but I do think that it can enhance some of the effects that we're planning on seeing on the 21st, or 20th to 21st, right, today and tomorrow, because the Earth is already going to be hopefully a little bit rattled. So this could extend the storming. That's my hope. Nonetheless, I do think that it's still going to be limited to high latitudes. I don't really think we're going to see all that much in terms of aurora at mid latitudes. I can cross my fingers. I've been wrong before, and so I hope I'm wrong again. But again, I think it's just little stuff, right? So that's why the gray shirt. So hopefully that answers that and lets you guys see that kind of thing. Now, whoops, sorry. I'll say switching to our moon, right? I'll let it go do its thing here now. So switching to our, whoops, now it's really messing up. Pardon me. Please do that. Okay, good. Switching to our moon, we are now passing through the full moon, with the full moon being on the 21st. And by the 24th, we'll still be about 87% illuminated. So it's going to be a tough catch with that aurora for you, for those of you who are going to be chasing, because you're going to have this big competitor here. It could easily drown out the aurora if the aurora ends up being weak. So keep that in mind, because that could, make or break whether or not you even go chasing, right? So only dedicated people should be chasing, I think, for this set of storms. Okay, and now I can go to my 5-day outlooks. Okay, so looking at our solar storm conditions and aurora possibilities over the coming week at high latitudes, I was thinking of updating this and just going from the 21st to the 25th, but you know what? It's still the 20th, so I'm still going to say that we are, we're on a storm watch. I was thinking that aurora is going to be likely, but as this thing takes longer and longer to get here, I'm not exactly sure if we're going to end up seeing the storm. I probably should have put storm watch here. I do that down below. But by the 21st, we definitely should be getting something, because that at least the second one, they both should be at least hitting by then. So NOAA's expecting major storm conditions with up to about a 65% chance of a big storm. Now, likely they will downgrade that a little bit because these storms are late, but we're still expecting some level of storming on that day. By the time we get to the 22nd, we should be calming down a little bit, but by the 23rd, we could have about another 15% chance of a minor storm conditions, again, from that other solar storm that looks like it's going to graze us to the south. After that, on the 24th and into the 25th, we should definitely be back to unsettled conditions with very little chance for activity. But, it's something. It's not great for high latitudes, but it's something for us. And sadly, at mid latitudes, the conditions are going to look even worse. We're going to have an aurora watch from today into tomorrow. Hopefully, NOAA's expecting minor storm conditions by tomorrow, even at mid latitudes. They may downgrade that a bit. I would think so at this point. We're probably going to be seeing active conditions at best, but we shall see. And it's simply because I know these storms are going to be super slow. They're not driving any big shocks, so they're not moving all that fast, and that has a tendency to really keep that aurora dim. So sorry about that at mid latitudes, folks, if you've been looking to get some aurora shots, for quite some time. We haven't had a decent solar storm for a while, so have to kind of keep your fingers crossed, but likely we're going to get coming into unsettled conditions. We could get a bit of a bump up on the 23rd. I'm saying about a 10% chance of a minor storm. Yeah, okay, maybe. I think it all depends upon what happens on the 21st. If we do bump up to at least active conditions, then possibly we could get some decent, maybe up to active conditions on the 23rd. We shall see. But that's really how it's going to shake out this week for you aurora photographers. So, only, again, I say only if you're dedicated should you chase. Now, this is good news for amateur radio operators and emergency responders because they don't necessarily like seeing aurora and disturbs conditions. on the night side. So, you know, it's always, there's always good and bad. Now, as we switch to our solar flare and Dayside radio blackout outlook over the coming week, we are sitting around 200 right now for the solar flux, right? This is not temperature, even though it might look like it is. This is solar flux. So, and this is radio flux, right? And it looks like we're going to be moving down a little bit. We'll have to see how old region 3733 turns out, if it's going to end up being the big flare player. If so, then these numbers will rise again, but expect them to dip down before they rise once more. We are having moderate noise on the bands. NOAA's giving us about a 55% chance of an R1 to R2 level radio blackout. That's an M-class flare. Also, about a 10 to 15% chance, I think they dropped down to 10% now, chance of X-class flares over the next couple days. That will likely stay the same. I've kind of dragged it out all the way through the 5-day because I just don't see that we're having all of that much activity. Plus, all of these active regions are beginning to rotate, you know, to the west limb. So I'm not thinking that there's going to be a lot more activity on the sun's far side outside of region 3733. So things are just going to keep it at about 50% by the end of the week, and that should, you know, hopefully cover things. Maybe things will quiet down even more than that. Now, as we switch to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D1 normal range. Basically, everything is in the green. This is a D1 normal is at the flight level 360 for you aviators. It's also the S0 quiet range for everyone else. We really haven't been having any big flare players that are driving radiation storms at this point, and don't really see, unless, again, region 3733 surprises us, I don't really see it in the foreseeable future. NOAA's giving us about a 10 or a 15% chance of a radiation storm. That's probably going to stay for at least until Tuesday or Wednesday of next week, and then it might rise a little bit as region 3751 rotates to the west limb. That always causes that risk for radiation storms to rise a little bit. But for the most part, we're pretty much in the green. You can watch the ICAO advisories, you know, for changes, but likely you frequent flyers and air crew, everything is going to be pretty good for you over this next week. Okay, and that's it. We have those big solar storms coming, but it's not going to be anything too intense. In fact, we've been waiting on them to arrive, the first real set of them, and yet we haven't seen anything yet. So Aurora photographers, if you're at high latitudes, you know, they could definitely get a show, but it will likely be dimmer than you'd like it to be. Aurora photographers at mid-latitudes, only sporadic shows are likely possible. It'll peak on the 21st if it's going to peak at all. But remember, you've got that moon that's going to be extremely bright, so that's going to be a big, you know, wet blanket, so to speak, for Aurora show, because it could really shine through and make those Aurora shows even dimmer. For you amateur radio operators and emergency responders, it's going to be kind of the same as before. Don't be worried about all those active regions in Earth view because they're not really doing all that much. So the noise floor is a little bit on the high side, but we're not expecting those big, long, you know, blasted R3 radio blackouts. So that's always going to be a good thing. And then GPS users, well, the storms on the night side probably won't be all that bad. So I'm not expecting all that much for you. Probably more trouble near dawn and near dusk where noise on the radio bands causes issues for you anyway. So just stay vigilant near there. And if we do happen to have a decent solar storm, then obviously stay vigilant anywhere near Aurora. And that is it, guys. So hopefully that gives you a nice feel for what's happening and why I'm wearing a gray shirt instead of a red one. I'll you know, stop and chat and guys ask questions and let me know. And I'll go back to anything you need me to, or we can do some deep dive if you'd like. Okay. Could be the calm before the storm. Yeah, I don't know. Let's see. Okay, you're welcome. And let's see. I'm trying to read. Stuff is scrolling a bit quickly. I guess I could put, you know what I'll do is I'll put the chat up here. There we go. So you guys can see your own chats. So thank you so much. I hope this wasn't too long. I didn't see how long have I been on? I don't know. Hold on. Oh, not too bad, I guess. Not great, but not too bad. Is that it? Yes, that is it for the BLUF. I can do Q&A now, so I can answer lots of questions if you'd like. Just let me know what you have in mind. So when will the HF bands improve? They should be improving a little bit now. This is Nick. You're asking me that question. They should improve a little bit starting now, and as these other regions rotate off the disk, the noise floor will go down, because it's just we have so many just little screamers, right? Think of a nursery of babies just screaming, and as you walk by them, it's like, oh God, okay. I mean, even I'm a mother, and if there's a nursery with a bunch of babies that aren't happy, then it's going to be noisy. And then as you walk further away from the nursery, then things quiet down a bit. So that's kind of what we're dealing with. That's why we're not getting lots of we have a high noise floor, but not a lot of really big solar flares. It's because it's not just one active regions that's causing all the noise. It's a bunch of little babies screaming in the nursery. Feed me or something. Are the other blips associated with the Carrington? No, not at all. These are almost the reverse of the opposite of the Carrington event. These things are mini, like wispy, gentle solar storms. Earth kind of just, Earth has them hit me, and they hit Earth, and Earth goes, did you feel something? Earth doesn't even know, don't even recognize there's anything going on. So don't worry about it. This isn't even close to Carrington. This is the easy stuff. Okay. Thank you, Jerry. Jerry will keep you in line, I tell you. Jerry and Mike, you be good, because they know how to keep people nice and cooperating with each other and playing well. We're all here to learn. And that reminds me. Thank you to all of you. I want to make sure that you are recognized for everything that you've done for me. On YouTube, I just recently passed 100,000 subscribers, so that's a huge milestone. And yes, I am getting the cute little plaque, and I will actually put that on a real forecast. I'll show you guys the plaque and thank you properly. So I'm waiting for it to be made. It's being made right now, and I just wanted to make sure that you guys knew how grateful I am. How grateful I am to you for that, because that was just such a, I never thought that I would be here talking about this kind of thing today. When I started all this, I did it to help people understand and not be scared, and I had no idea that it would turn out to be something like this. So thank you. Even though I've never considered myself a YouTuber, you guys have, to some degree, have turned me into one. So for that, I'm very grateful, and we're all learning together. So anyway, okay. Yeah, thank you, Nick. Congrats on your 100K. I appreciate it. Yeah, thanks, Ron. Thanks, guys. Well deserved. Thanks, Lee. I appreciate it. Do you get a medal? Yes, I do. It's a big plaque. I'll show you guys when it arrives. I'll show you. And if you happen to be on Patreon, I'll do like a behind the scenes, so you see kind of how the production and all the weird kind of communication that YouTube gives you when this stuff hits. It's very odd, but it's fun. Okay. Yeah. Thank you, guys. So. Okay, so what other questions? I'm sorry, some of the questions may have skated past us, and I didn't get a chance to see them. But hopefully, yes, as you guys know what the plaque looks like, it'll be a silver plaque. It's not a gold one or something. You have to get like 1 million subscribers for that. It's like, wow, crazy. But I just love the fact that you guys are all hard science nuts. And come here for the reality instead of the sensationalism. And that means a lot to me. It really does. So, okay, I've reached nerdvana. Yeah, I guess so. That's so great. Yeah, LQ for YouTube. I've learned so much from listening to you. Thank you so much. And I've learned so much from you guys as well. You really have helped me understand how you use space weather data and what's important of that. Or what's important about that, and how to tailor the forecasts I do to make them more useful and actionable for you all. And that's super important. What are the chances of another massive storm this cycle? Very high, to be honest. It's quite high. Our sun is waking up. It's not the same kind of sun we had, in solar cycle 23 and 24. So be aware that we do have the chances for large storms, but that does not necessarily mean, lights out, right? We already had a G5. Right? It was a baby G5, if there is such a thing, but it was a G5. So it was kind of nice to see that we've done pretty well, right? We did let's see, okay. That it's nice to know that a lot of the work that we've done has made a big difference. For instance, I think I might have mentioned back in May, I went to Italy to teach the school in L'Aquila, and one of the professors that because I was a co-director, one of the professors we got to teach a segment of the class, or one part of the course, was Antti Polkinen. And for those of you who don't know Antti Polkinen, he is a heavyweight when it comes to the NERC and FERC, the National Electric Reliability Corporation and the Federal Electric Reliability Corporation. I think that's what they stand for. And he has been working for 20 plus years to get these guys the right mitigation techniques and procedures during geomagnetic storms to minimize geomagnetically induced currents. And he and Jeff Love and a whole bunch of other people have been working on this for quite some time. And the thing that he told me, right, because we were there in May right after the G5, and the thing he told me was that it just made him, he was almost doing a jig. He was so excited and happy because he says what we're teaching them, what we're doing is working, because the grid rode through the G5 pretty well. There were some issues, but it wasn't catastrophic. It wasn't like the 1989 event. So we are working behind the scenes. Scientists and colleagues of mine and people I admire are working behind the scenes to get to fix things and make our world, our technology, space weather resilient. But it really helps to have all of this anecdotal information from you guys, because you let us know when and how we fail, right, and what we need to do better. And that is so invaluable, because we keep getting new susceptibilities all the time as technology continues to expand. And as you guys use it, use our technologies in new ways, we see new things break, right? Like the precision agriculture folks. That was a big surprise. We knew they were having problems, but we didn't think it would absolutely stop them in their tracks. So that was like kind of a wake-up call that we've got a new issue, a new alarm bell to ring. So, okay, let's see. Oh, tell us what it was like to watch Aurora from the plane. Oh my goodness, how much time do you have? Yeah, Mike, I will. Okay. I'll do that in a sec, Mike. Jerry, I'm seeing you have a question for me. And I'm going to say thank you to Arnold Schmidt, saying Dr. Tamitha is a great educator. Thank you so much. Henrist has a radio spectrograph for measuring solar radio bursts, which has got me thinking about solar flares. So here's a question. Why doesn't radio burst strength always match the X-ray flux? Because the X-ray flux is, it's not a radio burst, right? The sun shines just because you have electromagnetic light, and really X-ray light and radio light, bursts, that's all electromagnetic light. It's massless, right? There's no particles here. So when we talk about radiation from our star, electromagnetic radiation, we're talking about photons of light. That light can be X-rays, it can be EUV, extreme ultraviolet, that you can't see when you're on the ground. You can only see it from space because our atmosphere absorbs the extreme ultraviolet rays. You can have visible, which we can see, as long as it's certain wavelengths, right? Because we've got we have what we call the atmospheric window, so it penetrates all the way down to the ground. And then the window closes up again in the infrared, and then it opens up again in the radio, in certain frequencies in the radio band. Okay, that spectrum, right? It's just like colors of light, like the visible spectrum, but it's just a bigger spectrum. So there should be no reason why, if you have, for instance, let me just take the visible light. If the sun were completely flat in color, right, if every frequency of visible light had the same intensity, then likely our sun would be completely white, okay? Because you blend all colors together in equal intensities, you're going to get white light, right? But our sun isn't. Our sun actually is yellow, right? And anybody who says our sun is white, and that includes Neil deGrasse Tyson, he can go pound sand because he's wrong. If you look at a spectrum of our solar, of even just the visible wavelengths, it peaks in the yellow, okay? Which makes sense. Guess what color we are? We are all shades of yellow, guys. I hate to tell you this, anybody who thinks that we're not. We are sun-kissed by our star. We're either light yellow, right, like those of us who don't have much pigment, or we're super dark yellow for those of us who have a lot of pigment, which makes brown and even darker. So we are sun-kissed by our star, and it makes sense that we are yellow-skinned. If we had a blue star that peaked in a blue spectrum, likely we will have blue skin like, you can see on Pandora and Avatar, because we would be trying to reflect all that light to protect our own selves from that intensity of light in that particular frequency. So it's the same kind of idea when you expand that frequency range from X-rays all the way down to radio waves. Just because you have a strong X-ray burst doesn't mean you're going to have strong radio wave burst. The intensities don't have to be equal, if that makes any sense, right? So you can have a big radio burst in a certain frequency range, and you don't have it in an X-ray burst. That, in fact, is part of the problem that we have when we talk about radio bursts. Right now, the NOAA Space Weather Prediction Center has radio blackouts labeled through X-ray flux, which is wonderful when it comes to X-ray flux and EUV ionizing our upper atmosphere, okay, causing radio blackouts, causing skywave radio propagation to die. That's a great way of getting one aspect of a radio blackout. But there's a whole nother aspect of radio blackouts, and that's through radio bursts that we have no measure of. We can look at them through antennas and whatnot, but we don't have any scale, the G scale, the R scale, or the S scale. There's no scale for radio bursts. And that's a part of radio blackouts that a lot of people don't understand, is that you can get radio blackouts in two different, fundamentally different ways. One is lighting up the ionosphere through the X-rays and the EUV, and that's what we measure with the X-ray flux, and that's what the R scale represents. But when we have radio bursts, you don't always have to have a huge X-ray burst, okay, a huge rise in X-ray flux to get a really strong radio burst, even at really super high frequencies, like, let's say, the L band where GPS is, okay, or the X band where, actually the K band rather, the KU band, let's say, where Starlink is, right at 12 gigahertz. So it becomes a kind of a problem. This is a hole in our ability to do space weather, and it's mainly because space weather historically, when it was set up and the scales were set up, we cared far more about HF and UHF and VHF frequencies than we cared about, well, I shouldn't say UHF, but we cared about HF and VHF frequencies far more than we cared about the UHF and EHF and the higher frequencies that we'd use for satellite communications now. So we set it up to be, X-ray flux because that's all we needed at the time. We didn't even know that we were going to need in the future a measure of radio bursts, but that's what we need now. So hopefully that makes sense, and let me know if that didn't clarify it. So, okay. I'm going to black out, okay. Hopefully that wasn't too scientific. That's a good, someone's asking a good question. I think I missed it. Okay. Please explain, this is Helen Kennedy. Please explain the magnetopause position, solar wind, and show them movie graphs. I don't have magnetopause positioning right now. I mean, the best way to, I don't have those type of, any movies of that right now. I probably, I suppose I could go to the Space Weather Prediction Center and you could see some weak stuff. And it's just going to be models. Let me switch to here. Let's see. I'm going to take off the chat and go to my other thing. This is, by the way, since I have it up, I'm going to go ahead and refresh this. This is how I know the solar storms are not very intense. Right, so I'm looking at ACE data right now. So this is ACE data right now, and it's really kind of, this is the stuff we've seen over the last day or so. So we're getting some wake from some of the earlier storms. But how I know that we're not really looking at anything wonderful, I'm going to go ahead and intensify that to 7 days because you can't really see much movement outside of that. So this is EPAM data, which is particle data, what we call superthermal particles here. And if we were having a shock wave coming from being driven by a big solar storm, these particles would rise, and they would all be rising. But you're not. You're just kind of seeing a floating kind of blah, 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 blah. But they would rise very steeply, especially as the shock approached Earth. We're not seeing anything like that, so sadly, it looks like, whatever's coming is just kind of convecting in the solar wind. So it's a little bit depressing. But that's why, again, that's why the gray shirt. Okay, but in this mess, you might actually be able to see a little bit with the models here. Where is it? Okay. And I'll probably show it with the speed of the solar wind. So that's the first model here. So what you're looking at, this is the Space Weather Prediction Center page. Is it my favorite? Nah, it's okay. Bats or us is fine. What you're looking at is we're looking down at the North Pole from at Earth. The sun is over here blowing solar wind this way, okay? And that's what you're looking at basically the ecliptic, not the ecliptic plane, the equatorial plane. So Earth's magnetic equatorial plane. Dawn, they're showing you dawn is on this side, dusk is on this side, the Earth rotates this away. So if the sun is shining over here, as the sun rotates, as the Earth rotates this way, right on this terminator right here, that's where dawn is. And then it rotates to noon, and then it rotates to dusk, and the sun sets, and then you go to the night side, okay? So and again, we're looking down at Earth from the North Pole. Okay, so this is the night side of Earth, this is the day side of Earth. The magnetopause is this cute little fluffy thing that keeps going, okay? And the reason why it's softly undulating like that is because we do have some ripples of junk coming in the solar wind. You can see maybe slightly changing color from lighter orange to darker orange. When it goes to darker orange, you can see it's pushing in on the magnetopause, and when it goes lighter, when the solar wind is less intense, it kind of puffs back out. That's because Earth's magnetosphere is a magnetic spring. It's very springy, and it's trying to get a force balance in here. Okay, this is actually dynamic pressure balance. There is some magnetic pressure in here. The blue, I have said this so many times, I make myself sick. This is not solar wind going backwards. Okay, you are inside the Earth's magnetic system. The Earth's magnetic system, as I call the second chef, is akin to a chef that takes an egg that's thrown from the sun, cracks it in the near-Earth skillet, which is what this is, and scrambles it up, okay? There is so much dynamics going on, spinning all around in this thing. It's like a big mixing bowl, okay? So you do have particles that are moving toward Earth. In fact, you can actually see the slingshot. This is a vertical cut, so now we're looking down at the Earth from the North Pole here. This is the South Pole on this side. Again, the sun is coming this way, but it's a north-south cut, okay? Right through the center, right along the Earth-Sun line. Every now and again, you see something that looks a little bit like a wishbone. See this? Now, right now, it's kind of tilted because the Earth's magnetosphere is actually kind of tilted, or a little bit tilted right now. But you see this little wishbone? And you actually see, oh, there's a strong one right there. That wishbone is actually particles being slingshotted. You know what a slingshot looks like, right? Imagine a slingshot. You pull it back and you let go, right? You're going to shoot stuff, some stuff will get lost this way, but it's what we call reconnection, and it's shooting stuff forward. And that's why you see this blue, which is this color, 600 kilometers a second, this way, okay? The red is solar wind coming, or is particles moving this direction. Blue are particles moving this direction. Okay, that's what they're trying to show here. And any particles that you see that are moving this way, they're actually being slingshotted forward, and they're following the magnetic field lines up into the North Pole, and they're following the magnetic field lines into the South Pole. Hey, that's exactly how you create aurora. Okay, so this is not solar wind moving sunward. This is not solar wind moving sunward. This is dynamics inside the Earth's magnetic system, and it's doing exactly what it's supposed to do. It's reconfiguring the magnetic field, and as it does so, it does something we call dipolarizing, and it causes particles to be slung forward, and because they match, they have to follow the Earth's magnetic field direction and field lines, they penetrate into the North and South poles, which is why we have aurora in the North and the South. We always have particle precipitation going in like that, okay? This is completely normal. This cute little wishbone is totally normal, and it happens all the time, even when we aren't having big storms, like we aren't right now. On top of this, this is model, not data. We don't have a bunch of spacecraft measuring this stuff, Okay, it looks like I got a hot spot here. We don't have sorry, so my green screen's bleeding through. We don't have a bunch of satellites measuring all this stuff. Okay, this is a model that's predicting what is going on. Okay, so hopefully that makes sense. Okay, guys, yes, and Jerry, thank you. A reminder to everyone of the playlist of Q&A mini courses. If you want to learn more about this, how the magnetosphere works, look at my M courses. M for magnetosphere. Okay, my M series of courses, it will walk you through everything. Okay. Okay. Is the blue returning wind? No, it's not returning wind. It's doing dynamics in the Earth's magnetic system. I'm going to see if I can, I have something that fell here. I'm seeing if I can fix it. No, I'm just going to make it worse. Well, trying. I've got some sunlight, some stray sunlight that is peeking through a window, and it's ruining my green screen. Oh well, I'll try to stand here most of the time. So that's, again, this wishbone is actually dynamics. It's very well-known dynamics. We call it dipolarization. Okay, it's a very well-known dynamic in the Earth's magnetic system, where that reconnection is occurring, where you see kind of like an X. So you see part of that here. It becomes like an X line. That is near Earth neutral line, what we call the NENL, and it sits about 30 Earth radii down tail on average. And if you don't believe me, let's see. Oh, did we get it right? Yeah, about 30, see? So this model's doing pretty well, because we've crossed it with spacecraft enough times to know that this thing sits around 30 RE down tail. We also have a far Earth neutral line, but that's different dynamics than that has to do with recoupling to the solar wind. Okay, but this is dynamics in the Earth's magnetic system. We've known it for quite some time, and it is not solar wind that's heading toward the sun. This is trapped, or will soon be trapped particles. We call them bursty bulk flows. They flow into the poles. They actually stop. A lot of them break right at the plasma pause. They keep coming in, and then, depending upon what we call L shell that they're at, dictates their movement and what happens to them. Okay? There's a lot of very complex dynamics going on in the Earth's magnetic system. It's why I call it the second chef. So if you understand solar phenomena, you only understand half of the chefs cooking in the kitchen, because there are two chefs. There's the sun, and there's the Earth's magnetic system. Okay? You need to know both. Otherwise, you'll know enough to be dangerous, not enough to be right. Let me put it that way. Okay. All right. Look, the doctor is fixing the solar system live. Cute. Yeah, sun always tries to get the attention, but I tell you, the most mind-blowing dynamics occur in this skillet that the second chef owns. It's the most challenging to learn, to be totally honest. The stuff that comes off the sun is far easier, and I'm sure a lot of solar physicists would pelt me with olives for saying that. But if they don't believe me, come live a day or two in the Earth's magnetosphere and tell me it's not complicated as can be, because it really is. But it's really neat. It's really, the ballet that ensues is unbelievably beautiful and mesmerizing. So I definitely encourage you, if you haven't looked at my M series of courses, to look at them, because you will learn so much, and you will feel so much more comfortable with knowing what reaches us. Because as I oftentimes tease, that the sun is throwing eggs at us. The second chef grabs those eggs, cracks those eggs, fries them up in a near-Earth skillet, and we stand down at the ground with a plate, and what hits our plate is scrambled eggs. And we're looking at that thinking, wait, I know what an egg looks like. This doesn't look anything like an egg. Well, the reason why? Because of this guy, the second chef. Okay. Okay, Jerry Haley says there's a correlation of large earthquakes following large coronal holes and large semis. There's a correlation of large earthquakes at all times. Earthquakes correlate with everything. Okay, that doesn't mean that they cause them. And we will not, people can speculate all they want, and I love the French scientists who do that. And I get I get hit over the head every single time I say this with, by my geophysics colleagues, because they say, do not talk about this stuff. Don't hold up the French scientists in any level of with any level of admiration. And I will continue to do that, because I think French scientists need to keep plodding away. They need to keep working at it, because French science eventually becomes mainstream science. And not everything that French scientists do becomes mainstream. A lot of it is debunked, and that's fine. But they keep coming up with ideas, and that's good. But as I've said many, many times, I keep saying it over and over to people, French science gives mainstream science wings, but mainstream science keeps French science grounded. We need both, okay? And mainstream science doesn't always have the funding, and will not get the funding until it's clear that there's something really going on that is worth chasing, because that's taxpayers' funds that have to be spent this way. So the mainstream science field is very, very critical of the work that's done and that gets funded, and that's okay. But with that being said, the idea that we could actually chase the source of earthquakes in a robust and honest manner right now with the level of space weather knowledge we have, or even the level of geophysics knowledge we have, is silly. Because geophysicists can't even predict earthquakes to the level that they need to in order for it to make sense to anyone else to chase a secondary or a tertiary driver of earthquakes. Okay? We already know space weather is not going to be a main driver of earthquakes. It's just not. But could it be a secondary or tertiary driver? Sure. But until you are able to predict the primary drivers of earthquakes well enough that you can subtract them out, you're never going to get a repeatable way of chasing after the space weather component or the tidal component with the moon, right? I mean, we can think of mechanisms all day long, right? I've thought, for instance, I say this all the time, the piezoelectric mechanism with GICs might very well cause stresses to be induced in the Earth's crust that could, potentially cause low-level forces that then could exacerbate an already unstable condition. So you can think of mechanisms, sure. Can we test those mechanisms? No, we can't, because we can't even suss out the primary drivers well enough. So we have to give geophysicists more time to be able to get a better hold of their science. And people who try to push geophysicists out of the way because they've got their own pet theories really don't do themselves any favors. So I honestly say to French scientists who work in this arena, but don't attack geophysicists because they don't, they don't feel that what you're working on is ready for prime time, because even what they're working on is hard, right? And they've got a better handle on what the primary drivers are. So that's all I say about that, because I'm tired of seeing geophysicists and French scientists who want space weather, who want so badly for space weather to be a major player in earthquake, in seismic, and in geology. If space weather really were that big a player, trust me, space weather physicists would be all over it, because they would get so much funding. You could probably win a Nobel Prize if it were that easy. But it's not. It's really not, because geology is extremely complicated. Okay, but please play nice with each other, because we all have a seat at the table. Okay. Anyway, that's all I have to say about that. Okay, scrambled eggs, pancakes, breakfast for dinner. Cute. Well explained. Thank you. You're very welcome, Eric. I hope that helps. Yeah, liquefaction is a new concept in geophysics. I mean, there's so many things. Geophysics, to me, geophysics is like climate science. It's really hard, and everything is a feedback system, and there are just so many different states that people have to pay attention to and try to understand. It's just incredibly difficult. Even geophysicists that are trying to understand why the Earth's magnetic field, and I'm probably going to open a really bad subject by even talking about this, but trying to understand when and if the Earth's magnetic field flips, if it's just an excursion like what we're going through right now, or is it going to actually flip and instead of recover? We don't even know that, because we've seen excursions like this before, even deeper ones that we've had that we're in right now, and where the Earth's field just kind of recovers. It doesn't even, the dipole field component doesn't even flip. It's such a convoluted science. And the energy input is so, I don't want to say completely stochastic, but there's just so much to think about and so many different nuances that it makes it extremely challenging task to even get models to represent what reality is. So anyway, I'll stick with space weather, thanks. Okay, oh, I love the flip thing, yeah. All right, guys, any other questions? As a matter of fact, let me check on Patreon to see if anyone asked me questions there. I'll refresh. Hold on. Oh, I did have someone that posted, I think, in the... Okay, hold on. I'm going to make sure this doesn't play. Do not play. Okay. Let's see. Mark Montgomery says, it's a pleasure to join you. Thank you, Mark. Holly says, first live, woohoo, cool. That's great, Holly. I hope you're enjoying it. Joe says, wow, so much going on makes me dizzy. Yes, no kidding. It was so hard to keep straight, I tell you. And that was Joe, WC4R. Gerald Smith says, does the Earth have a different electrical charge compared to the current released by the sun? No. Everything in space is what we call quasi-neutral. And here, I'll talk about that for just a second. Everything is quasi-neutral, and the reason for that is because charges are moving pretty freely all the way around. They're governed by the magnetic field, but they still are moving pretty freely, and lots of little electric fields are set up everywhere to keep the charge, charges reasonably neutral. So anytime you have a surplus of electrons, you're going to have ions rushing in. Anytime you have a surplus of ions, you're going to have electrons rushing in. And if you don't get that, what helps that along is the isotropization. Am I saying that right? When you basically isotropize, or if you don't know that word, homogenize, right? You're making everything the same. There's lots of waves that grow, especially in the Earth's magnetosphere, which is one of the things that makes it so challenging. And those wave processes grow to try to make the particle distributions much more even, either to a Gaussian or Maxwellian distribution. And so we have lots of different processes that are always active, scattering particles, changing things around, bending magnetic fields, creating electric and magnetic fields not creating magnetic fields, but creating electric fields to bend magnetic fields and change things around, and in order to try to get to the lowest energy level, right? It's entropy, right? It's always working at it. And the lowest energy state for a dipole magnetic field, which is the dominant component of Earth's magnetic system, is a dipole, right? A nice smooth dipole. So that's why we call about dipolarization and all this stuff. And you see particles being slingshotted into the North and South Pole. It's dipolarizing to try to lower its energy state. Oftentimes it will cause substorms when you get dipolarization. And it doesn't have to be even driven by the solar wind. So when we get the sun, shining and doing whatever it's doing, it's throwing out particles in the solar wind. We have the superthermal, we have the heat, what we call the electron straw, the heat flux. These are all different distributions in the solar wind, and they're always kind of acting together and thermalizing. And so to say that you're going to have one polarization for the sun and another polarization for Earth, it's not quite like that. Plus we get things like photoionization even, where we have photons actually ionizing different aspects of our upper atmosphere, of satellites, and all sorts of things. It gets very complicated, but overall, nothing is neutral in space, and it's always kind of, nothing is neutral in the sense that there's no like molecules, neutral molecules in space. Everything is ionized. And so you have lots of free-floating pluses and minuses floating around. And so they all will kind of organize in such a way as to keep things quasi-neutral, which is often, which is actually why we have a Debye sphere around spacecraft. If anyone ever wondered why a magnetometer has to be on a super long boom? Have you ever seen these things? You have electric antennas have to be long, but then you have to have this magnetometer on the very tip of this very long boom. It's because it has to get itself out of the Debye sphere of the spacecraft, because you have this field of ions and electrons that build up around a spacecraft because of this quasi-neutrality. So the magnetometer has to get outside of that sphere. If it doesn't, then it won't read the right magnetic field. It'll read the magnetic field of the spacecraft instead of the environment. Pretty wild, huh? Yeah, it's space is hard. There's lots of stuff you don't have to deal with at Earth that you have to deal with out there. So hopefully that answers that, Gerald. If it doesn't, let me know. Whoops. Didn't mean for that to go quiet on me. Okay, let's see. Any other questions? Spock's daughter, you say, 3 questions. Is this cycle agreed being unusually strong? Not unusually. Okay, I'll talk about that more in a sec. Any guesses on how long middle max of 25 lasts, and how is max determined? Okay, so this solar cycle, is it unusually strong? No, it's not unusually strong. We've had multiple people, especially Bob Lehman and Scott McIntosh and the NCAR, UCAR crew, who predicted this. There was also a couple other scientists who predicted it for a different reason. Oh, and I'm trying to think of who it is right now. I apologize, I can't think of his name. It'll come to me. I'm sure it'll come to me when this stream is over. But anyway, so it was already predicted, not by the consensus from SWPC, but rather by another team, that we were going to be coming out of this grand solar minimum, and which we've been kind of sliding in for the last 3 cycles, essentially. From basically cycle 22, we've been kind of really sliding down. So we went through 21 was a big cycle. I think 19 was the peak. Then 20 and 21 were kind of, one was a little bit smaller, one was a little bit higher. And then we had this slow decline from 22, 23, 24. It was all going down. And then it was predicted that we were going to come out of it. So, and sure enough, this cycle we are coming out of it. It's still smaller than a normal cycle. As a matter of fact, I can just show it to you. Right, don't you? Yeah, solar cycle progression, sure. And I think if it loads, can I go further out? Yes, I can. Yeah, so you can kind of see, I'll do it from here. So you can kind of see. Oh, I'll stand in front of that nasty thing again. So you can see the rise to the grand solar maximum. Up to here, cycle 19 was the peak, like I said. Then cycle 20 and 21 were kind of, we had a little bit of a dip. And then right around here, you kind of began, so imagine this was an anomaly, and we still don't understand everything about our sun yet. It still holds mysteries. So why this one was a bit smaller than we would have expected. We would have expected a nice, slow slant down. But we still consider this the grand solar maximum. So as you can see, the last few cycles have been getting smaller and smaller and smaller. And then cycle 24 was, the deepest part of the minimum. And a lot of people expected cycle 25 to be, just as small, if not smaller. And some people, of course, expected that we were not going to have any sunspots at all, that the cycle was going to be so weak that sunspots could no longer form even on the surface of the sun. I mean, the solar dynamo still works, but when the sun's magnetic field isn't strong enough, the magnetic field isn't buoyant enough to pop through the surface. So if you think of sunspot clusters like submarines, they've got to have enough buoyancy to pop through the surface if they expect to rise and do periscope up and all that. Well, when they don't have enough buoyancy, then they can never surface, right? Well, that's what happens with the magnetic field when we have these really weak cycles. The magnetic field is still doing what it's doing. The cycles are still doing what they're doing, but they just never rise to the surface to create sunspots, okay? So that's why we get the Maunder minimum, for example, where the sunspots disappear. But in this case, we are coming out of the solar minimum, right, the grand solar minimum, and we're rising. And as you can see, we're a little bit bigger than this cycle. Not great. You can tell we have cycles far, far bigger. And this is what I've been talking about if you've been watching some of my recent mini courses where I talked about the analysis of the big events. I talk about, go back and look. You guys think that we have big storms now and you're freaking out over these little puffs and things and, oh, the Carrington event is going to come get us. Not with cycles, you know, where most of the activity is pretty minor, right? Can we have big events? Yes, we can get very big events in low activity cycles like ours. But you're not going to get everyday events being nearly as intense as you do with these bigger cycles, especially radio bursts. We were talking about radio bursts earlier. This is where we had some of the most intense radio bursts. We're back in the 1940s, 50s, and 60s. It was unbelievable, the amount of intensity of the radio bursts. And that's actually what I'm more concerned about, to be totally honest, than even a Carrington event. I'm worried about radio bursts that are just nonstop and what that's going to do, because we're just so not ready for it. Anyway, back to today's solar cycle. Yes, we are seeing more intense events. I'm seeing events in this cycle that remind me of cycle 22. This is where I cut my teeth in grad school, was looking at events from this cycle, right? Because I was actually in this cycle, but I was looking at events from the prior cycle. And I'm finally beginning to see, after multiple cycles of not seeing events that looked familiar, I'm seeing events that remind me of cycle 22, when the sun was a lot stronger. So that's telling me that, yeah, we are coming indeed out of this solar minimum. Now, as far as how long is it going to last, the solar maximum phase, it's likely going to be double peaked. We are seeing the first peak now. It probably will diminish a little bit for a little while, but that's not going to be that solar the maximum is going to be over. It probably won't be over until about the 2026. Then we're going to start the declining phase, and you'll know that because you'll see the big coronal holes. As a matter of fact, if I go back to let's see, here. If I go back to this, and I go back to the front, come on. Give me here. Right about there. Yeah, right there. Yeah, sorry about my green screen. See this hole? Right? This is, you can't really tell. I'm trying to block the green screen as well at the same time. But this is a big coronal hole right here. Okay? This, you'll start seeing these coronal holes. See how it's kind of flat-lined right here? This is how we know we're at solar max. This thing's flattened out right about 55 degrees. It's pretty cool. But when we start getting in the declining phase of the solar cycle, you'll see this coronal hole become trans-equatorial, meaning it will cross through the middle. And we'll see these things become very, very big. This is when everybody freaks out because our sun's tearing in half. No, it's not tearing in half. It's just a coronal hole. It's just part of the cycle. It's the declining phase always has these big trans-equatorial coronal holes, and fast solar wind comes from them, so we get hit every 27 days by the same fast solar wind stream. And there'll be strong fast solar wind. So it will cause big, decent-sized geomagnetic storms. G1, G2, easy. Not typically a G3 sometimes, but it usually means that there's a transient in there as well. But yeah, that's what we get to look forward to. So that probably won't happen until 2026. Okay, we'll start seeing that part of it. So we do have another, year and a half or so to go through the rest of the solar maximum phase before we really start on the decline. Hopefully that answers that question. Okay, and I think that's it for the questions there. So thanks, guys, for all of that. Mike, I'll have to talk about my viewing the Aurora on a plane while flying to Italy. I'll have to talk about that at some other time because I don't want to keep everybody on for too long. But that is definitely a fun story. So I will definitely definitely make a thing. Maybe I'll do it on Patreon and give you guys, and I'll show you all the videos and stuff like that I took, and so you can see, because I literally watched Aurora from dusk to dawn because I flew all the way across the night side, and I got to watch Aurora change. It was my very first time seeing Aurora, and it was remarkable. But what was very, very cool was that I got to see all different types of Aurora as I cruised all the way across the auroral oval. It was very, for someone who was a scientist, it was just the best first experience that I could have ever imagined, and I'm very grateful for it. So I will definitely share it at some point. So, all right, guys, outside of that, hopefully that was, that's enough. So enjoy, if you're at high latitudes, enjoy the weak aurora. Remember that bright moon. It could be getting in the way. And for those of you who are afraid that there was just so much stuff going on the sun and it was going to cause all sorts of problems, don't worry. Everything's cool. Okay. All right. Okay, guys, I will talk to you soon, and have fun. Have the fun of the rest of your weekend.